Hello and welcome to Algebra 2, Section 6.3, Logarithmic and Logarithmic Functions. So, we've been working a lot this chapter with exponents, and more specifically, the variable x in the exponent. So let's say it's something like 2 to the power of x equals 4. Well, we all know that 2 squared equals 4, and therefore x has to be 2 right there. Same logic applies here. 2 to the x equals 8. Well, 2 times 2 times 2 equals 8, which is the same thing as 2 cubed equals 8, and therefore x be 3. However, things get a little goofy when the numbers don't work perfectly. For example, 2 to the x equals 6. I can see that because x equals 2 there gives us 4, and x equals 3 gives us 8, it has to be between 2 and 3, but never quite clear. But mathematicians have created what are called logarithms. Logarithms is a way to solve these. So log base b of y equals x if and only if b to the power of x equals y. So if I'm talking about this last one, we just had 2 to the x equals 6. That is the same thing as log base 2 of 6 equals x. Now, why go to all this work? Well, thankfully, in my calculator, I can actually have a log button to sort of solve these things. So that helps us figure out what x would have to be. For example, I could type log base 2 of x. So that'd be under math. I'm going to go to log base 2 of 6. I can type it in, and I would see that x is about 2.58. Now, it's important to know that that is under Math A for log base. Because if you just press the log button, you can't adjust the little number right there. See how I wanted to get that 2 there? I can't put that 2 in there if I just press log. So let's talk about how I went about rewriting this. Well, if I look at it, this and this match, this and this match, and this match. The way I've always thought about it is a spiral. I start with whatever number's right here, and I spiral outwardly like that. So this would be 3 to the 4th equals 81. So if I type 3 to the 4th in my calculator, I should get 81, which I do here. Same idea here. I'm just going to spiral it, starting with this bottom number, to the power of 1 equals 7. 7 to the power of 1 equals 7, which we all agree is true. 14 to the power of 0 equals 1, which is also true. 1/2 to the power of -5 equals 32. So the spiral is how I can go from log form into exponential form. Well, thankfully, the spiral also works as long as you start with the base number. So 7, 49, and 2. So log base 7 of 49 equals 2. So if I type log base 7 of 49 in my calculator, again, going to math, down to A for log base 7 of 49, we get 2. So that is a true statement. Next one, 5, or 50, so log base 50 of 1. If you want to think about it, there's little parentheses in there, equals 0. Log base 4 of 1/4 equals -1. Log of 256, log base 256 of 2 equals 1/8 because spiral. Let's try a couple of different things here. So, common log, as I talked about earlier, when I just pressed the log button, you can't change the number. So, if you press the log button, it's assuming base 10. That's kind of like the default setting. Same thing if I press the natural log button. It doesn't have a number right there. Log and natural log are the same kind of thing. Natural log is when base is E. It's the same thing as doing log of E. Remember, E is a number from yesterday. Okay. So rewrite in exponential form. I would spiral it, but I don't have a number written there. So if there's no number written there, it's implied to be 10. So 10 to the fourth equals x. No number written there, but it's natural log, so it's an e. So we get e to the 0 equals 1. Rewrite in logarithmic form, so spiral it. Log base 10 of 10,000 equals 4. Because 10 is there, I either can just leave this as my answer, or I didn't have to technically write it. Either is fine. Same idea over here. This is an e, so I'm going to say natural log of 148.4 equals 5. Or if you want to think about it as log base e of 148.4 equals 5, either's fine. Evaluate the logarithm. That just means we're going to type it in our calculator. So log base 2 of 32, like I said earlier, math A for log base 2 of 32 gives us 5. Log base 27 of 3. We get 0.3 repeating. It says 3 decimal places, so I'm just going to go right there. Log of 12, we get 1.079. Okay. And natural log of 0.75, we have negative 0.288. Okay. Next slide. Inverse properties. So inverse just means they undo each other, like, plus and subtract undo each other, or multiplying and dividing undo each other. So if I have this number, this log base, and that base number together, that'll be the exact same number, this whole thing cancels out. So 3 and 3, the log 3 and the 3 undo each other. I'm left with just the exponent. The same works is if I have that base number with an exponent of that thing, they cancel out, I get there. So for example, 4 and log base 4, they'd cancel, giving me 2 equals 2. So this one, there's no number written, so it's log base 10. Well, the 10s cancel, giving me just 4. And you could also double check that in your calculator. For example, 10 to the power of log of 4. It gives me exactly 4 because it's doing that cancellation for you. This next one, I have log base 5 of 25. Well, those aren't the same numbers. So what we have to do is check 25. Can I write 25 as 5 with an exponent? Well, that's obviously true, right? Because if I break down 25 as 2 5s, that's really just 5 squared. So I know that 5 squared is the same thing as 25. So all I'm going to do is replace 25 with 5 squared. So I have log base 5 of 5 squared to the x. Well, the 2 and the x are getting multiplied, so I get log base 5 of 5 to the 2x. And now these numbers are the same, which means they cancel out, and all I'm left with is 2x. Thank you for listening, and I hope you have a wonderful day.